So I figured, fuck it, what's the difference? One day you can't bring yourself to do something, the next day you can do it.
Always been built to last. Sometimes it takes a while. Recognition is seldom fast. There are many inches in a mile.
Honey, you'll never believe what happened to me today.
So, gentlemen, that's how it is. Until Grissom resurfaces. I'm the acting president, and I say, starting with this anniversary festival, we run the city into the ground.
And what's with that stupid grin?
Life's been good to me.
Hello. Alright, we're going to do our daily GLSL shader coding session.
We'll just shake hands.
Just give me a second now, I can actually fix this up. There we go. Noisy, but it's good. Hold on. Actually, wait, maybe I can make this even better. Yeah, it's noisy, but it's not bad. I don't know how I'm gonna get rid of the noise, but anyways, hello. Wait a minute. There we go. Make the light less yellow. Still very yellow. And now I'm gray. Yeah, we're just gonna leave it. Anyways, let's get started. So today we are gonna do some more work on the deferred path tracer. I don't think we're gonna finish it, but oh yeah, and so I've got most of the renderings done now. Let me actually show this. So these are the renderings of high quality renderings of the animations at up to 4K. Beauty. So you can watch these all at Ethan's renderings. And I still have more to upload. But I've also decided we may not do like an art quality scene each day. We're just gonna do some daily shader coding. Because there's sometimes when I really like, there's times like I push to go and say, oh, I need to keep working on this until it's like high quality, worth posting, and I think it's more just about practicing the coding each day. It's not about creating something amazing. The reality is some stuff is a dead end. Alright. Just trying to remember. I think it's DPT0. Yeah, okay. I'm just going to set up the options for this. So here is a path tracer. That's a short little animation. We're going to switch this up today to actually go along a bunch of repeating spheres. And change up the materials. Okay, so let's add the repeating spheres and the materials. So we're going to need to add the repeating spheres in the geometry here. by repeating X and Z. Just like this. And then we're going to point the camera straight down this time. There we go, so there's our spheres a little bit closer together. Oh yeah, there's also something I want to change with the path tracer. Right here when it reflects, we're actually going to check this, the ray direction. Facing the other direction of the normal, which means it's going to hit the surface again. Then we're going to set it to the random direction. Oh yeah, so that made it brighter because more rays made it out. But you can actually see there's little artifacts now where the rays penetrating to the surface. So we're going to back up by twice here. Yeah, now there we go. Okay. Because of the way the epsilon works, we might actually need to back up here instead of here. Or back up at both. Right here we'll do times minus epsilon. Nope, didn't make any difference. Okay, so it must already be good. We'll actually probably be able to tell once we get more in depth. You can see the artifacts right there. Yep, that did fix it. Okay. Alright, I still want to put the spheres closer together. That might be good. Alright, let's just try completely together just to... Other than making it darker. Alright, not bad. I think we're gonna put them pretty close together. Yeah, like that. Alright, I think I'm gonna zoom in so we can see more. And I'm gonna make it a sunlight. Some actual nice decent background shading. I feel like something's wrong with that. Not enough shading. I think we should maybe attenuate out the background based off of the distance. It's like how I did before. That'll be full brightness when it's 10 units away. Perfect, there we go. Very nice. Alright, now we're gonna add a like a sunlight.
Leur argent à tous ceux qui en avaient si peu, tandis que les riches barons, trop puissants pour que l'on ose s'attaquer à eux, se gobergeaient dans leurs donjons.
That made no difference. Why did that make no difference? Oh, that ×2 is in the wrong spot. There we go. Let me actually look at the sky just so I'm sure I'm doing this right. Here we go. Awesome. So yeah, okay. That's gonna be noisy because of how bright the light is. This is gonna be where the deferred path tracing is gonna shine. We're gonna blend together a bunch of these samples because of the data we have access to on the G buffer.
5, 4, 3, 2, 1.
You know, I think we'll leave the angle like that. Okay. Now we are going to make the spheres different materials. Ooh, yeah, we'll make it with different materials first, but yeah, then I think I'm gonna do the deferred sample blending. Alright, so to make them, we'll make them different colors and different roughnesses. Hey, Ack. So we're going to need to floor this to, I think, 1.2. So divide this by 1.2, and that'll be the seed for our hash. And then our hash gives us the random color and roughness we want for this. First of all, let's try the random color. There we go. Oh, so that's interesting. Ah, I forgot. It's also going to color the blocks. I'm going to set the floor to be white still. That looks cool though. Oh, and there's actually a little bit of a artifact there. Oh. I know what that is. I need to apply this, it backs up the ray a little bit. Yeah, there we go. So that fixed it, but I need to back, oh, that's interesting. So I need to back up the ray a little bit there and a little bit right here. That's a nice pick thingy. I am coding a ray tracer right now. Right here, we were actually doing this before. We need to sample. Oh, so the material's already sampled, so we just do minus epsilon here, and should be good. Remember me? Yep. Huh. That. Hard to tell if that made a difference. Oh, I wonder if it's because I'm not doing what I'm doing here, where I check whether or not the surface is actually good. Let's see if this fixes it. Huh. Yeah, I think that did fix it. It's hard to tell though. I'm going to point it down. These look not rough enough. Yeah. So before, these looked a lot rougher. So curious, let me try taking away the sun. How do you do that? Open GL shaders. Okay, that's weird. There's no sun, but it still seems to be directed. That's weird. I gotta figure that out. Hold on. I actually think that might be correct. Maybe that actually is how light is supposed to bounce off the surface. Well, let me try it without. Oh yeah, so that, I swear that's how it's supposed to be. Way rougher. Yeah, this is how it's supposed to be. Even if it's different, that's what it's supposed to be like. Because technically, oh man, that's so crazy, because it simulates the ray going back into the surface. Huh. Or the ray bouncing around in like the, because the surface is actually almost like a little mountain area. So it's technically like the ray bouncing between two mountain area. Oh man, how do I describe this? Yeah. Anyways, let's shift the roughness now and fix this up. Okay. With the sun, and if the Y is smaller, to this small value. This is going to be the floor, which I'm going to make dark gray. Oh man, or do I want to make it white? I think I'm going to make it white. That didn't do anything. Oh, there we go. Equal to -49. Yeah, it's kind of bugging out there. Let me think about this. Okay, we want to sample the material after backing up, I think. Ooh, this is a hard one. Because technically this is like a precision error. I'm actually super curious. So like, how inaccurate is that backing up? Let's try removing that. Interesting. I gotta get this consistent so that there's not these bands all over the place. How do you do that? Vector math. This programming language GLSL is designed around it.
Every time the music stops, you can be the sound you hear.
Okay, this might not be working the way I think it is. Plus 0.5. So this means 0 is at 0.5. Yeah, so this should be smaller or equal to negative 0.5 volts. Oh! I realize now. So this is hitting the own surface in this part, which is then out. It's now backed up. Oh, okay. So wait. Yeah, maybe we do need an epsilon at or. Yeah, I honestly don't know a solution for this. What did I do before? Before I just dealt with it here by shifting this by the epsilon. But I want to deal with it by offsetting it correctly closest to the surface. That effect is really cool, how it makes it shiny. I almost feel like I should keep that as its like own effect. There we go. So then, I'm pretty positive if I take this away, it'll bring back the issues on the ground. I guess not. Hold on, I'm gonna put this really close to the ground so we'll be able to see. That is nearly in a sphere. Here we go. So that, you know what? That looks like it's working. Oh, it's hard to tell though. right there, it's hard to tell if it's like reflecting off the floor. No, I think that's correct. It kind of is reflecting off the floor. Oh man, this is so tempting. I don't know which one to do. The rough or... oh man, maybe I'll actually do 2 roughnesses. So if, like if roughness is negative maybe, and then I'll encode. Yeah, you know what? I'm doing this. We're doing both. Wait, do I not pack the normal here? Oh my god. I think the normals are bugged. Normal times 5. And then here, back times 2 minus 1. Oh my god, I wasn't packing the normals correctly. Alright, here, if roughness is negative, then we're gonna do the flipping like that. Alright, now let's try different roughnesses. I'm actually surprised, did that not really change anything? I would have thought the normal not being encoded correctly would have done that, but maybe not. Interesting, yeah, they both give different results. Oh, that's smaller than -1. It's supposed to be smaller than 0. There we go. That's interesting. Okay, I love that it supports these different materials. Now... alright, different floor colors. Yeah, so that way I know the color isn't bleeding. Alright, now we're going to do varying roughnesses. So some are going to be shiny, some are not. Which way should I put the camera for this? I almost feel like I should start moving the camera again. Looking pretty nice. Let's put the sun at more of an angle. There's a bit of artifacts there. I'm not sure if those will... I think those might even out. I think that is caused by it hitting the surface. Let's try changing this. That didn't do anything. Oh, I think that's the normal being sampled inside. No, I just think that's I don't know what it is, because it shows up in all of them. Well, I have a decent idea of what it is. The ray penetrating the surface. You can always try backing up more from here. See, it's hard to tell if those are actually going to average out or not. I have a feeling they aren't. Back in World War II, how did it go? Oh, you can see the same thing happening right here. I wonder if it's actually just low epsilon. How do you make it? It's math. It's simulating light rays bouncing around a grid of spheres. Does that make it better? No. that different, you know, in the games? Yes. Kind of. Depends what kind of games. Alright, I'm gonna try and fix this. I have an idea of how. What are you making this thing for, though? Realistic rendering. It's useful for a ton of things. Like, this can be used for video games. Or this stuff applies to video games, too. Right now, this is calculating the normal of the geometry using the derivative of the distance function. Let me just put this into a video game. You can make a video game out of this. Unexpected token. What? Alright, let's count these. 1, 2, 3, 5. Unexpected. Ooh, where? Let's try counting again. Oh. Yeah, I missed. I missed one. I miss another one. This is some brutal code to read, so... Oh my god, I removed a comma. There we go. That did not work. How do you even get the programs for this? OpenGL is pretty old now, but this website Shader Toy is actually really popular now. Like programmers, everyone shares their shaders here. Got basically everything, so you can learn a lot from here. For example, it is pretty slow though. Old RCTV. So the epsilon here is actually pretty good, which is, the epsilon's the precision. These are precision issues that I'm trying to fix. Which makes me think that these precision issues are coming from right here where the epsilon is bad. Let me try lowering the epsilon here. Ooh, that actually seemed to make it worse. just making your own. Yep, exactly that. Making my own programs. Let's try upping the epsilon. Well, that helped it a little bit. Did that fix it? I think that just fixed it. Huh.
J'étais près de toi, oui mais dans mes bras, ce n'était pas toi. L'amour à plusieurs.
Yeah, so interesting. This is not random. Not random at all. Those kind of look like eyes. Have you ever used .back programming? Yep. I got some .bat scripts, compiling stuff here. Very simple, but it is .bat. Can you teach me some lessons? No. The internet can though. There's so many good .bat lessons. You just search up list of .bat commands. It'll normally give you an example with each command of how the command is used. And .bat commands are really just programs on the computer, so it's really powerful. Why they gotta do this? Why they gotta... what? Alright, we're switching the music because of that. Okay. I almost feel like supplying two positions, one for the color, like helping PMD. I don't think that gives you everything though. That just gives you the basics. And I don't think that's well, like, documented in the sense that it's not good for learning. What if I make the normal based off the epsilon? Low epsilon. Alright, and now this X value, epsilon, is going to replace any up. There we go. So this hopefully should make it dynamic and better scaled so that there's less bands. Too few arguments in call. That's right here, yep. Interesting, so there's a little bit less banding on here. Try to delete System 32 in a virtual machine. I can just create a folder called System32 and delete it. Okay, so what is happening here? The epsilon getting so big it's bugging out. Maybe do half-sized? They're making it bigger and smaller. That's weird, it looks better in some places and way worse in others. Oh, there we go. That's for the most part really nice. And I think those lines are actually the ground. And I should be able to apply the epsilon to this. Oh yeah, there still is a little bit of artifacts right there. That's better. Oh, that's nearly perfect. I think that's it. Try and get bigger. Oh yeah, lower is definitely better. I'm too low. Too low gives you bands as well though. Need it like just right. I'm gonna try backing up the ray a bit more and see if that helps. Try backing it up a bit less and see if that helps. That made it worse. Yeah, that did not work. Yeah, you know what? I'm fine with that. That bit of banding. That looks pretty good right now. Okay, I'm gonna smooth this out now. I think right here in the post-processing pass is where we're gonna apply it. Oh, yeah, so there are actually a bunch of artifacts right here. Oh god. Oh yeah, so the artifacts are as it gets farther away. Hey, username GRFI. You can see those lines right there. The epsilon gets low. How to fix that? Let me just try removing this just to test. Oh, that brought more artifacts. We're backing up less. Nope. Try bigger and smaller epsilons. Oh, that actually made it a bit bigger back there. But better. Interesting. I might just end up wanting a constant normal epsilon. And it's not that much of a difference. Let me try backing up just a little bit more for this. Ooh. That looks like it worked a little bit. It's probably really hard to see on the stream, but I'm just trying to fix these super small bug or artifacts right here. There in the corner. Zoom in on them here. See right here. Those lines. So that's either the normal being imprecise and banding, or it's caused by the ray going into the surface, which I don't believe it is, because then it should affect the coloring if the ray's going into the surface, and it's not really that much. It's more the brightness. Oh my god, I just remembered how I fixed this before. Dithering. So, when the ray starts here, when we do the camera right here, we do RP plus equals ray direction times, so we have our random hash here. So we're going to take that random hash. It's called pixel hash. PH for short. And now right here we're going to offset the ray randomly by the pixel hash. Ooh, close. Close. I think that made it better. So now each ray is a bit randomly offset. I guess that isn't the issue at all, though. Yeah, that literally did nothing. Ah. Well, what do you know? Oh, I don't think I just offset the position. I think I actually also offset and jittered the step position. So I believe that's it stepping into the surface. Let's try backing up a bit more and a bit less. Didn't change anything. Okay. We're doing the last thing. We're debugging. We're outputting the normals. We're seeing if this is an actual issue with the material normal itself. Oh god, wait. Still path tracing. Yep, okay. You can see the issue with the normals here. Awesome. So that is actually completely visualizing it. So that's interesting. We didn't even notice it, but it's actually, or I didn't even notice it, but it's actually down here in the ground too. But you can see right here the normal flipping upward due to where it's sampling. Okay, so this is gonna be an interesting fix. Or whatever fixes this is gonna be interesting. I don't know what's gonna fix it yet. Let's try backing up the ray a little bit more. I almost wonder if it's the compression. I don't think so, but oh, that made it better. The epsilon's smaller. You know what, let's try not... right now we're doing the forward derivative, let's do a centered derivative. That is what we did before. Let me see if the code's still here. It is not. Okay. So if we go back far enough. There we go. That's the centered derivative right there. My cat comes in the room and it hears me talking and it just sits there and it just stares at me like, so you're talking to me, right? You're gonna pat me, right? Oh, this is wrong. See how this works. That definitely looks different. How are you doing tonight, Griff? GRFI. Definitely seems like that centered derivative is better. Confined. Well, that's good. That looks weird. Yeah, it's debugging. It's outputting information of the surface direction, so I can test see these bands easier. Like rainbow ice cream, yes.
Alone inside my forest room and it's stormy. I never thought I'd be in bloom, but this is where I start. Telling days of stereo pits for the all-night crowd that cannot, and I'm calling. Tedious ways that the media pays for the animal gets for the animal, and I'm sorry. Stadium, Arcadium, a mirror to the moon, and I'm falling, and I'm warming. I stayed in the yard until the clouds come crashing. Strange rains have happened both before and afternoon. Well, I'm falling, and I'm warming. I'm pushing myself and no, I don't mind asking.
Interesting how the floor goes down in the forward or in the center derivative. I assume the recursion arrays is all in some shader. It is all in the shader. Right here bounces the ray around. Calculates the new ray position based off the surface, and it just keeps the ray going for 50 iterations.
And this is where I
Ooh, that almost looks like it made it better. That fixed the bottom. Hold on.
kind enough to disavow. This is where I stand. Stadium, Arcadium.
So now there's just minimal bands here. If I can add noise to this. Oh my god, my cat literally lied under my chair. It's like it's trying to get me to trip over it or something.
Stadium, Arcadium, a mirror to the moon.
Oh yeah, I don't need to worry about any of this. Oh yeah. Choose between refraction / refraction at random for each ray. It doesn't support transparency right now. It's all solid colors. It just reflects. Alright, I am confident that I can get this. It's looking so good now. Yeah, so the epsilon isn't making any difference. Alright, I'm gonna try more offsetting the ray if I can. Oh! Oh my god, that fixed it! Oh my god, that fixed it. But it added, it starts going into the spheres right here. Ooh. Hold on, let me try something. Okay, so moving the ray forward a random bit definitely helps. Like, so much. Let me see if I can get it. Okay, the ideal, so the issue still is though that this requires me moving the camera essentially forward by like 1 unit plus. The ideal thing is to have it support going super close. Like what this basically means is nothing can be closer than a unit to the camera, which is really bad. A unit is like a meter plus in some cases. So there has to be some other way to maybe even just dithering this. What if I just randomized the amount that it backs up right here? Like add a little bit of dither going into the surface. Let's use the hash function for this. Yeah, still no. Oh. Maybe I am on the right track. Yeah, so it needs a really big random value to actually make a difference.
The will of God is standing still. Brazilian children get their fill. Let's go. Let's turn it up and dumb it down. The vision of your road was sounding so. And all the leaves are turning brown. The wind is pushing me around. Let's go.
Ooh. That actually looks like it's getting values from there it wasn't getting before. What's happening there? I tried backing up. Oh, interesting. What if we try going backwards and forwards? So that isn't... Hold on, okay. Now let me try... I removed the averaging the frames. We're gonna do that now. So if this actually works correctly, this noise should average out. Should average out to be smooth. No, it did not work. It averaged out to be bands again. Another way to inject noise in this. I think, like, just to test this, I'm pretty positive this fixes it. This is what I did last time. Like a pseudo random hash. Makes the array move at different amounts. That almost did it. Let me try ramping this up more. This will end up with a lower view distance though, I believe. Oh my god, it's smooth. So there we go. That's the solution right there. That looks perfect. That actually looks perfect. Oh my god. Completely smooth. Yeah, so there it averages out. Okay. Okay. This is our goal now. So this is slow. Making the distance only move halfway randomly. What we want to do is we want to find a way to add these random ray steps only close to the surface. Really, all we need to change is this sampling, I believe. Oh my god, is it? Is that all we need to change? Yeah, I think that is. I'm gonna be honest. I'm going to be happy if this just looks perfect and is fast at the end of tonight. Because this path tracer, I've been putting it off for a while, and I said the other, like 2 or so days ago, we're just going to start this, and we're going to work away at it, because once it's done, it's basically going to be the foundation for rendering fractals, rendering a whole bunch of procedural scenes, and it's just so good to practice and learn. Okay. My whole thing is, though, we're already adding this right here. Is there some way we can include it in this? I feel like all we need to do is add a little value to this DT. And so the random pixel hash doesn't look as good. As wasteful as it is, I think we're actually going to do a different hash right here. More into 2D stuff at the moment. 2D stuff is also endless. It's just as big as 3D. No, that didn't do it. Yeah, I do think I need to randomly jitter this. Nope, I literally cannot find anything except for randomly moving this. Well, if that's what it takes, let's figure this out. It needs quite the bit amount of dithering, but I don't think it needs to dither all the way. I think it just needs to dither when the distance gets close. So maybe if we literally just do an if statement, if distance. Oh, maybe we should probably make this smooth actually. Let's just do this if statement first. If smaller than 1, then start randomly dithering it. Otherwise we just do the normal distance. Oh! That did it! Oh my god, yes. Oh, so how close? How small can we get this? I'm gonna try and scale it based off the epsilon. Oh, there's a little bit of banding there. Let me just start zooming in on this just to make sure. Yeah, you can see a little bit of those waves right there. Let's try doing this as a smooth function. So as it gets closer, it should shift to this random value. Oh, that looks like it works. Yeah, that's good. No waves. Oh, I should debug iterations though. That's what I can use this last field for. Here we go. Okay, so this is going to show iterations. So we can actually see how much more expensive this is getting. So, brighter is more expensive. Darker is cheap. Ideally, we want a lot of this to be dark. Okay. So you can see this is kind of where the bands are being caused. So this actually doesn't... This isn't too bad at adding new iteration, or adding more iterations, just a little bit right here. The main issue is that this is a whole new... Like, this code being executed 40 times is actually more expensive. Like, the main part is actually having to execute this 40 times as well. This lerping, multiplying, mixing, clamping. So I have an idea now. Now that I'm seeing this, we're gonna try backing the ray up nice and small. No, it is not that expensive, but my goal now is to back up the ray Wait, why is this not... Oh, I'm multiplying it and then setting it. There we go. So right here, I think we can just back up. So we don't have to do that whole mixing and random, like pseudo-random generation just for those few steps that it's going to be doing at the end. My idea is that we get to the end here and we back up and then retrace it with the random generation just for a few steps. One of the things I am thinking is though is what am I going to do here where it's like right here when it's in the loop. We can't really do that. I'm just thinking the banding isn't going to be that bad in the reflections. But it shouldn't really matter. I'm just thinking we have a hash right here. So technically we can back up the ray randomly, which should solve any issues. Yeah, so okay. Right here before it sets the new ray. Back up the ray direction by the epsilon. Ray hash. Is that used for anything? Alright. Why? Okay, nope. Alright. Let's try backing this up. Remove the iteration coloring so we get full visual. Wait. This is basically going to be the same thing as doing... I already did this. Randomly backing it up by doing plus epsilon times hash. Can try it again though. Why not? What is that? Oh, I did the subtraction at the wrong part. Alright, I was trying not to do the full thing, but we're actually going to back this up. And I'm going to retrace it. Gonna back it up by a random amount. Oh yeah, and then we can retrace this with the higher epsilon. It's actually going to be good. It actually partially did it. Oh, it's because I'm not even using it there. There we go. I just changed it so that it backed up so far that it won't even get the surface, and it still rendered it. And I was like, wait, I obviously didn't connect it properly. Here we go. So that's interesting. That gives it the effect of it backing up randomly, and it almost like blurs them together. Oh, there we go. That looks like it did it. There's a little bit of bands there. Hard to see. That looks good. Oh wait, actually it's got these bit of artifacts right here. I wonder, did it have those in the other version? Did it have it? Let me try this just with the random mixing. No, it didn't. That's much more perfect. Compare these two. No, yeah, one has... This one is so much better. Oh my god. I've made a gut. This has been a fucking 2-hour stream of surface normals. Alright. I'm determined to get this though. So that looks like it has less artifacts. Oh, interesting. So the artifacts were it not tracing all the way. Ooh. Oh, there we go. That did it. That's perfect. And it's cheap. How little iterations can we get this in? Ooh, yeah. So now it's still curved there. But the normals are great. Let me just tweak it a little bit now. How does the hash change it? Yeah, so some of the errors might actually be coming from the hash. Yeah, so I think that... Oh yeah, I'm so happy with that. That's so much better than what we had before. Even if there's those little wobbles here, it happens. Oh, it's got the large view distance though. It blurs out in the view distance, so it basically has proper aliasing, and it's still nice and quick. That's awesome. Okay. Let's turn back on the path tracing. There's no artifacts. It's beautiful. It's beautiful. Okay, now the floor is still... Floor isn't done. There we go. Oh. There's our path tracer in all its glory. So, I'm gonna... Yeah, that'll be it for tonight. Oh man, I did not mean to make this a 2-hour stream of messing with normals on spheres, but we did it. It's a crucial step of making sure this works properly. It's not something that's easy to explain either unless you understand the math, because really it's a tiny visual effect, but you're basically choosing between like this allows me to get this super far view distance in 40 ray marking iterations while still giving decent quality. Like, it is so beneficial to have worked that out and still made it look smooth. And now we're basically just going to be able to do everything normal and not worry about like how our detail function here hooks into the epsilon. Oh, you know what I never tried? I never tried going back to the unsigned normal. Yeah, so that has issues. So we are going to be using the signed central normal from now on, which is all good. But one thing I was hoping to do today until I ran into that normal issue is we're going to be fine. Actually, the main part of the deferred path tracer is right here. When we go and combine the lighting samples with the G buffer, we're actually going to go around to the nearby lighting samples and combine alike samples, because so the roughest surfaces here that are the noisiest, you can actually see here the kind of reflective, that's like almost a gold reflective sphere right there. But you can actually see on that sphere, you can see the sphere that's reflective is not noisy at all, or like very little noise. It's actually a nice smooth, and you can see the reflection of the sun there. And you can see like these reflective spheres, it's a lot clearer. But then if you go over here to like these rough spheres, you can see how noisy it is. So basically what we can do here is we can go and calculate, hey, these surfaces are basically the same, and their ray directions both share, like they're both rough surfaces, and what we can do is we can blur them together. And it solves a lot of the noise. So that's going to be the main denoising effect of the deferred path tracer. That should help it converge so much quicker. But yeah, that's going to be pretty complicated, so that'll be a whole stream in itself, I'm betting. I gotta go. Have a good evening. I get way too into ray tracing, but there's our daily GLSL stream. Also, just a reminder, I haven't put it up yet. The link will actually be on the Twitch page. I'm gonna do that right after I end the stream. To my new YouTube channel, Ethan's Renderings. I've uploaded 4K 60 FPS renderings of all the art scenes I've done for the past like 3-4 weeks. So thank you for watching. See you around. Have a good evening. You're looking at Math Canvas. Oh, thank you. I made that for myself. Wolfram Alpha can't do certain things. So being able to like program for loops and things in JavaScript is, oh, you can do so many functions.
Gonna come and get you when I hit you in your potty clothes.